Assalamu alaikum. In this video we will see a problem on the about hydrostatic force on any curved surface area. So let's see the problem. Here said that a cylindrical gate. This is a cylindrical gate of 4 meter in diameter. 4 meter in diameter means this cylinder is in 4 meter diameter and means its radius is 2 meter and 2 meter long. If we visualize the 3D model, then means it is 2 meter long, has water on both sides. In this left side it's also watery surface and in right sides there are also watery surface. As shown in figure, this is the figure. Determined the magnitude and direction of the resultant force exerted by water on the gate. Means we have to find out the magnitude and direction of the resultant force that exerts this and this watery surface upon the cylindrical gate. Find also the least weight of the cylinder so that it may not be lifted away from the floor. This is the floor, suppose. So we have to find out the least weight of this cylindrical gate so it may not be lifted, means the vertical force will be the equals the weight of the cylindrical, then the cylindrical gate will not be lifted. Or if the vertical force is higher than this the weight of the cylindrical gate, then the cylindrical gate will be lifted, and if the vertical force is less or equal the cylindrical gate, then it not be lifted. For the curved surface, we know that here works the force which is perpendicular to the surface area. So if we have to find out the forces, we will divide this into vertical and horizontal terms. So suppose this is the vertical terms and this is the horizontal terms, means this is the vertical force and this is the horizontal force upon this curved surface. For this figure, the left side watery surface will give a force which is horizontal to this cylindrical gate, and for this left side area, here the vertical force will work here. Suppose here is a line, the vertical force will work here, and the weight of this fluid and this fluid will work lower weight. And for the right side watery surface, the horizontal force will work like this way and the vertical force will work like this way. Fy, they are both vertical force, and Fx, they are horizontal force. As in the question, we have to find out the resultant force. So we see that this Fx1, Fx2, this Fx1 is in direction and Fx2 in the opposite direction. So we will consider this plus sign and this as minus sign. And for the vertical force, they are in the same direction, plus plus. So we will add these two forces and we will find the magnitude of these forces. For our better understand, let's see the 3D model of this figure. This is our left side watery surface, this is the cylindrical gate, and this is the right side watery surface. This is the upper view of this figure. Now let's see the front view that we are seeing in the figure is this kind of figure. Here this is 4 meter and this is half 2 meter of the cylindrical gate, and the diameter of this cylindrical gate is 4 meter. So here the one horizontal force will act like this way, and the horizontal force of right side will act like this way, and the vertical force will act like this way, and the another vertical force is act like this way. Let's first understand the left side portion forces. We said that this is the horizontal force that works upon this cylindrical gate. This is the force that this water exerts upon the cylindrical gate, and the same magnitude of this force will act like this way because of the reaction of this force which exerts by the cylinder. So this force exerts on which surface? We will see this surface, means this surface. We saw that this is the height of this cylindrical gate, which is 2 meter long, and this is the diameter of this cylindrical surface, which is 4 meter. So the area that this horizontal surface exerts on it, that is 4 into 2 meter area. Now see the vertical force that exerts on this surface. This is act like this surface, and the vertical force will act like in this way. So which area upon this vertical force works? this is the radius of the area and this is the length or width of the area. So if the lower part of this portion area surface, the vertical force will be act towards that watery surface. They are upon the water. This is the same on the right side, just half of the left side. Let's do the math. Here in the question they are given that the radius of this cylindrical gate is 4 meter and in length it is 2 meter. Now first of all we'll see the forces for the left side of the cylindrical gate. Let's find the horizontal force first. Horizontal force will denote as Fx1, which is rho g h a. Here how much the h is? From the upper part of the watery surface to the lower part of the watery surface divided by 2, means thus where the centroid of this fluid works at the middle of this fluid. So total h divided by 2 means 4 divided by 2 means 2. So this will be 100 into 9.81 into, here height is 4 divided by 2, the centroid of the fluid, into area. We saw the portion of the area is this surface area, means the radius 4 meter into the length of the cylindrical gate, which is 2 meter. So the area is 4 into 2. So this force will be 156960 Newton. Then see the vertical force, which is Fy. So here the Fy will be rho g h a. Here h will works as the total surface, because the vertical force is works at the lower of the surface. So it will count the total height of the fluid, means the upper surface to the lower surface, because it works in the lower, and the horizontal force works at the centroid of the force. So we took the half of the height. Here we will measure the height as 4 meter, and the area, we saw the area of the force that creates this surface, the radius of the cylindrical gate and the length of the cylindrical gate. So here will be 1000 into 9.81 into height is 4 meter and area is, so that length is 2 meter and radius will be also 2 meter. We will took this part, so 2 meter. So it will be 156960 Newton. But here we have to see the weight of the cylindrical gate. We took this portion. Here the vertical force Fy works. Took this. Here the vertical force Fy works. But the weight of this water and this water acts towards the down of the cylindrical gate. So they are in the opposite direction, this W. So we will also count this weight force. Then the net vertical force will be, suppose this is the F dash we have measured, then the net vertical force will be Fy prime minus y naught. Why minus? Because they are in the opposite direction, and we took upper as positive and lower as negative. Let's find the weight of this and this fluid. So the weight of the water surface of the left side area, we know that rho equals to m by v, then m equals to rho v, so weight equals to mg equals to rho vg. So the weight will be w1 rho gv. This will be 100 into 9.81. Now what is the v? V is the area into length. We know that length is 2 meter, but what is the area? We have to understand the area. This is the figure that we have to count. This is the half circle, and this way the vertical force works, and the weight of this area and this watery surface works at lower. So how will we have to find the weight of this and this area? Let's find out the area of this and this portion. First we will find the area of this rectangle, and we will minus the area of this half circle. Then we will find the area of this portion, means we will first find the rectangle area, then we will minus the half circle portion, then we will get the area of this portion. So the area will be, the area of the rectangle means 4 in diameter and 2 in length, means 4 into 2 minus half circle pi r² divided by 2 into length 2. Here we got the weight as 33683.616 Newton. So the net vertical force will be Fy equals to Fy prime minus W. This will be 12376.384 Newton. Now we will got the half side portion of the left side forces of the cylindrical gate. Like this way we will also find the right side of the cylindrical gate. Now we will see the right side forces. This is the horizontal force for right side, which is denoted by Fx2, which is rho g h a. Here h how much? The half of the fluid surface than the left side. So if the cylindrical gate is this, then the height is this. And where the hydrostatic force act, half of this fluid means at the centroid of the fluid. This is 2 meter. So this will work into 1 meter. And the area of this is this surface. This surface is 2 meter radius, and 3D model, according to the 3D model, the length is 2 meter. So the area is 2 into 2. Then this is the horizontal force. Let's see the vertical force. Fy double prime, which is rho g h. Here the h will be total height from the upper part of the fluid to the lower part, because it is the work into the lower portion of the cylindrical gate. So we will measure the total height in the expression, and the area is the half of the radius, and this half of the radius, and this length, which is also 2 meter. Then we got this vertical force. Then here also the vertical force work as this way, and the weight in this. So they are in the opposite direction. So we will have to measure the net forces. So we'll find the weight force of this watery surface. Here, as the vertical force works like this, and this water force act like this, so we will have to find the weight of this surface. If we measure the area of this rectangle and minus the area of this 1/4 quarter circle, then we will got this portion area. So the area of this portion rectangle is 2 into 2, and the area of this quarter circle is 1/4 of the equation of the circle. So we will got rho g v. Here A will be the area of the rectangle minus the area of the quarter circle. So we will got the area of this portion into the length of the cylindrical gate, which is 2 meter. Then we will got the weight of this water is the Newton. Then the net vertical force will be this vertical force minus the weight of this water force. Then we will got this vertical force, which acts the right side of the cylindrical gate. As the vertical force of the left side and the vertical force of the right side works in the opposite direction, so the net force Fx, horizontal force, will be Fx1 minus Fx2, as this in the opposite direction. And we see that the vertical force both are in the same direction. So the net vertical force will be Fy1 plus Fy2. Then we will find the net force as F equals to Fx square plus Fy square root. Then we will got the net force. So the total horizontal force means Fx1 and Fx2 force acting on that cylindrical gate is, we will add two side forces, right side and left side horizontal force, but as they are in opposite direction, so we will use the minus sign upon the right side force. So we will calculate the Fx, and similarly we will find the vertical force that acting on the gate. Then as they are in the same direction, so we will add to these forces. Then look at this picture. Suppose Fx is working like this way and Fy is working like this way. So if we want to find out this resultant force F, then what we have to do? According to vector analysis, we know that if we want to this resultant force, we have to sum square both these two forces and root this. This is how we got the resultant force F upon Newton. And now find the direction of this force, in which direction this force works on the cylindrical gate. Let's consider that theta is the angle in which angle the force is acting on the cylindrical gate. Suppose this is the theta, then we know that the theta will be tan inverse Fy divided by Fx. So this is how we find the angle of theta. Now the second question, at this question of not lifting the cylindrical gate, we have already said that if we don't want to lift that cylindrical gate of the floor or from the floor, then the weight of the cylinder must be equal or less than the need vertical force. We got the need vertical force Fy equals to this Newton. So the least weight of the cylinder will be also this. It can be lower from this, but here said that least weight, so we have to consider the same Newton force as the vertical force. This is how you can solve this problem. I hope you understand.